This is Mr. Spensei, your stats sensei, and this is scenario 3 on 2 sample T. And we're going to run a hypothesis test, confidence interval, and this is going to close out our examples for this section. So a statistics teacher wanted to know if males can navigate through a maze faster than females. And that's actually going to get us a little bit confused. So I'm going to scratch that out, the word faster, and you'll see why in a moment. A random sample of male and female students was selected, and the times it took them to complete the maze were recorded below. Determine whether or not there exists a difference. Here's why I changed that, guys. So they're looking for difference, and whenever we see the word difference, we know it's a not equal situation between completion times for men and women. Let mu equal the true population mean for females. So this is mu1 is the females, and mu2 is the males. All right. So first thing we have to do, write our either do our parameters, which we just said, mu1 equals true population mean for females, mu2 true population mean time for males. The assumption is that there is no difference, and please remember this could have been written as mu1 minus mu2 equals 0. And this could be, since there's difference, it's not equal, we could have written it as mu1 minus mu2 does not equal 0. Either one of those would have been correct. And you need to keep them both in mind because they will show up like that on tests. Conditions. We have to satisfy all our conditions. Random sample is given for both. And by the way, if you just want to sit there and go random sample is given for both and write it once instead of, that's fine. You can do that. You wouldn't have to write it over here. Samples are independent. Reasonable to assume that female maze times are not affected by males and vice versa. All right. So we could have said that that's and taken care of that for both sides. 31 divided by 0.10 or 31 times 10, there are more than 310 females at Reagan, and 19 divided by 0.10, there are more than 190 males at Reagan. This one I would have had to do in both locations. And this gets a little bit different. We have a sample size of 31 over here. So we can say the distribution of means is normal by central limit theorem for female times. But over here, we only have 19. All right. So I'm going to have to do a box plot. So the very first thing I'm going to do is enter my data in the stat edit because I'm going to need to do that anyway. In L1, I put the females, and L2, I put the males. So there's everybody's data. And then I'm going to go to y equals just to make sure that everything is cleared out. I scroll all the way down. It all happens to be cleared out. We're all good there. That'll get rid of some errors. I'm going to go second stat plot. And I only want one of them on, so I'm going to turn the second one off. Okay. And I now have stat plot. I want it on. I select the box plot that shows outliers. All right, and press enter. Now, the data I'm concerned about are the males. The females were normal by central limit theorem, so I'm going to press second, followed by the number 2. And I should be able to press zoom 9. And I get here is, you know what, no outliers, reasonably symmetric, kind of fat. But anyway, and I use the trace feature to get my data values. And so I sit there, the box plot of the male times reasonably symmetric with no outliers. Distribution appears to be normal enough. Now I can get all of my information one of two ways, and I don't want you to forget about this. I can go stat calc, 1 var stat. Second one gives me L1, and this will give me all my female information. So I have an X bar 175, a standard deviation for the females is 79, N is 31. And I can scroll all the way through and actually get all my box plot information. Stat calc 1 var stats, and I go to L2, and I get the same information for the males, the X bar 164, the standard deviation for the sample of 81.75. Scrolling down, we see all the box plot information. Now, to be truthful for these, I just go stat test and drop over to number 4. And I have data, and my data is in L1 and L2. And I want to make sure that I have not equal highlighted because that was our alternative statement. We never pool, and I get a ton of information. So X1, 175, plugging that into my equation, 0.26, minus 164.68 over the standard deviations. All right, and notice I have different sample sizes. Notice I put a 2 times out here, because what we ended up doing is we go, you know what, the female times are greater than the men's. This difference was greater than greater. So I'm going to say that it was, because this value was greater, I'm going to put a greater than sign for it, but that's only making it one tail, and this is a 2-tail test. I need to put it 2 times. Now the calculator will handle that behind the screen, scenes, which it did. And when we ran it, we got a t-score of 0.449, which is a positive. So this is what this really means. When we ran this test, we ended up with a t-score of, 0 is the center for the t. We ended up with a 0.4490. And we found the area of this. But we had to go 2 times that because it was a not equal situation. Because just as extreme as 0.4490 is negative 0.4490. And the area in between those 2 tails, together these 2 areas sum to 0.656. All right, and I know this wasn't part of the problem, but I'm going to take a moment and do this. I'm going to go stat test, 2 sample t-test, and I'm just going to turn this into a greater than and run this as a greater than. And when we do this, I still get this t statistic of 0.449, but now look, 0.328, that's my p-value. And if I go 0.328 times 2, sure enough, I get 0.656. So the calculator does it behind the screen, but we need to say 2 times that. Well, our p-value is 0.656, which is greater than 0.05 by a lot. So we're going to fail to reject a null. So in this case, there's not sufficient evidence that alpha equal 0.05 to suggest the difference in the true population mean maize for females and males are different. That, that the true population times for males versus females are different. On average, female and male maize times are not statistically different, right? Technically, they're different because this is less than this. So there's evidence to say that there's difference, but it's not statistically significant. All right, next part, the confidence interval. So they want us to create a 90% confidence interval. And notice in this case, I went ahead and wrote mu1 equals mu2. This is not required. Sometimes it helps us out, but it's not required. I'm not going to redo the conditions. That took a lot of time, and it's on the previous part of this video or in the notes borrowed page 2 of 3. So let mu1 equal the true population mean time for females. It's definitely doing that. Mu2 true population mean time for males. Once again, I could have gotten all this information from stat calc 1 bar stat. And since I did that, I could start plugging it in. But I'm going to go ahead and run this thing, stat test. I have to scroll down a ways to 2 sample t interval, which is at number 0 or 10. Press enter. I have data. We're changing our confidence level to 0.9, a 90% confidence interval. We're not going to pool. And we get a ton of information. And we notice that we go from negative to positive. All right. So that's going to be important. We go from a negative 29 to a positive 50.29. All right. And we also get degrees of freedom. This is huge. Please make sure you write this down because that's going to help us find our T-star. We have our X bar of 175.25. And for the boys or the young men, 164.68. Sample standard deviation for the females is 79.28. And for the males is 81.75. So at that point, I can plug those values in. This is the X bar female. This is X bar male, standard deviation female, standard deviation male. Plug those in, but I still don't have T star. So as a reminder, second vars, inverse T, parenthesis, 1 minus 0.90, close parenthesis, divided by 2. Because all confidence intervals are two-tailed tests. Our degrees of freedom happen to be 37.29. We end up getting 1.686. And that's where that number came from. Okay, so this is my T star. This is, excuse me, T star with 37.29 degrees of freedom. So in conclusion, we are 90% confident the true population mean difference in May's mean times between females and males lies within the interval -29 to 50.29. By the way, that decimal should not be there. Make sure it shouldn't be there, but I don't believe that decimal is supposed to be there. Yeah, that decimal is not supposed to be there. So this is 29.15 and 50.29. In repeated sampling, we expect that this method will capture the true population difference in May's times, females and males, 90% of the time. Note, 0 lies within interval. Therefore, there's not a statistically significant difference between female and male times. Based on our samples, it appears that both females and males times are the same. Okay, or you could say, or are not different, if that made you more comfortable. Or are, you can say, are not different. Right? Please remember, we didn't prove this. We just say, hey, we can't say that they are different. All right. Thank you for watching and study up, and I'll see you next time.